Okay, so this video is a follow-up for classwork 4, and it really covers kind of the second half of that classwork. Um, since the other video I posted really covers the first 2 pages, we're going to skip right down to page 3, and I'm just going to talk you through some of my thoughts and some of my answers on this classwork to try to answer any lingering questions that people have. Okay. So hopefully you've already had a chance to kind of struggle with this classwork, really think about it. Some of you, I've been glancing through the answers and I've looked at the discussion boards, and some of you have great ideas. So this is just to kind of clarify things so you're not sitting there thinking like, well, was it right? Was it right? Okay, so this is the scenario where we're comparing 2 different cancer drugs, drug A and drug B. And they measured, okay, for terminal cancer patients who were given each of these drugs, how much longer beyond their expected life, their life expectancy, how much additional life did they get, essentially, is what they measured. And they measured this in terms of, uh, is it months, I believe? Uh, 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 mm. Yeah, well, I don't see it written in here, but I'm pretty sure these are, oh, here we go. Assume the number means additional months lived. Okay, so as I suggested, I'm going to go ahead and put these in order first, because if you look, they're not in any sort of order, right? So it helps me to think about, so instead of eyeballing and seeing like where's the low, where's the high, I'm just going to put them in order. So if I put them in order, it goes 5, 6, 8, 8. So that's 5, 6, 8, 8. And then 9, 12, 18, 21, 18 and 21. Then we've got 23, 23, 24, and 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here we can see I've got drug A in order. And so now it's easier to see, okay, the person who got the most, or the lowest advantage lived an additional 5 months. Person who got the best advantage lived an additional 25 months, or over 2 years. And the mean for this group was 15.17. So the average additional life that patients using drug A got was about 15 months, so a year and 3 months. Now drug B, I'm going to do the same and put them in order. So we've got 9, 13. How many of these 15s? 1, 2, 3, 4. Okay. 15, 15, 15, 15. It's these ones. And then we've got 16, 16, 17, 17. Did I miss? Oh, I missed a 13, didn't I? Let's do that over. All right. So we've got the 9, 13. We've got 2 13s. And then 4 15s. 2 16s. 2 17s. And 22. So it should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So again, now I can eyeball it a little better. The person who had the sort of the least benefit lived an additional 9 months. The person who had the most benefit lived an additional 22 months. So just shy of 2 additional years. Okay. So why could we argue that drug A is better than drug B? So often, if I'm looking at these, I can see drug A, the numbers, there's a wide range of numbers, right? All the way from 5 up to 25. That's a huge range. So I could live an additional 5 months, or I could live an additional 25 months. So, how could we argue that drug A is better than drug B? Well, if we look, I mean, one, two, three, four of these people got over 2 years, right? Versus if we look at drug B, nobody made it to 2 years. So we have some of the longest survival rates with drug A, right? So your chances of living 2 years or more, way, way better with A than with B. With B, nobody lived more than 2 years more. So how could we argue that drug B is better than drug A? I'm going to just bring this up a little here. Well, again, if we're looking at these two, so with drug B, sure, nobody lived, over 2 years, but like the lowest already beat out four from group A, right? So if we look, these numbers seem to be a lot more clustered around this middle section, whereas here jumps from 12 to 18 and 21. There's a lot of variation here. So with drug B, I would say it looks like drug B is kind of more consistent. Like you're probably not going to get 2 years, but everybody except one person got at least a year, 13 months and up. So if you want at least a year, really drug B is where you want to go. If you're hoping for 2 years, well, drug A is where you want to go, but it's more of a gamble because how many of these people didn't even make a year? One, two, three, four, five. So 5 of them didn't even make it a year. So it kind of comes down to how much risk are you willing to take? Are you the kind of person who you want to risk it to go big and hope that you're one of these people who end up with a lot of more months? Or do you want to play it more safe and say, well, like, at least I'm going to get, like, looking at this, I'm pretty likely to get at least a year. I'm not going to get 2 years, but at least I'm going to get a year with B. So here, honestly, there's no right answer for it's a personal decision for everybody. And a lot of it comes down to your risk tolerance, whether you like to gamble, what you're aiming for. But either of these cases, I mean, we could argue drug A is better because you might live longer, you might live 2 years or more. Or we could argue that drug B is better because at least you get a year. Right? It's more consistent. So at that point, it kind of depends on what are you looking for. Now, imagine that somebody looked at those means, right? So we had the mean for A was 15.17 months, and the mean for B was 15.25 months. So in both of these cases, it's around 15 when we find the average of all these numbers. Okay. So imagine someone looks at these means and they summarize, well, with drug B, it's a little bit higher, right? It's 0.08 higher. And if you figure out 0.08 months, if you convert that into days, it works out to about 2.5 days. So on average, the people who took drug B had 2.5 more days than the people who took drug A. So does it make sense in that case to say that, well, drug B basically helps you live 2.5 days longer than drug A? Is that a pretty accurate statement? I mean, if we look at the numbers, that's not really telling the full story, right? We're missing a lot of information. So the means make it seem like these two are really, really similar. But when we look at the numbers all written out, they're really not very similar. This one has a much lower low and much higher high, whereas this one is all clumped more towards the middle and it's more consistent. So it's not really a very good statement here, right? It's really more like if you take drug A, it seems like you're either going to live more than 20 months or less than 10. But if you took drug B, you'll live somewhere in that in between 10 and 20 range, right? So it's not the most accurate of statements. And so if all we had was the means, you might miss a lot in that interpretation, right? You may say, they're about the same. You get a tiny bit more with B. But really, that is not telling us the whole story, as we can see in our histograms. Now, I hope everyone got this one right. So which one's the bar chart? Remember, bar charts are the ones that we can use to show categories. And so this one will be our bar chart. And this one shows our histograms, right? And we can see here there's no gaps in between. We have frequency or count is on our y-axis, and our survival months is on our x-axis. So one thing you should note here is what we have here, survival months, is what we have down here, survival months. And so this is going to kind of play out in a couple of questions. So when we're looking at these, if you look just at this bar chart, if you didn't have the histograms at all, if all you had was this bar chart, then you would look at this and say, okay, the survival months, like they're almost the same, right? They're both about 15. And so what this bar chart is showing us is these are the averages, right? So this for drug A was 15.17. So really, if we were to like trace this out, it's 15.17. So this is going to help us with number 8. So the top of this bar is the average for group A here. And then the top of this bar is that 15.25, the average for group B. Really close. And so when we look at the bar graph, it looks like both groups are basically the same, right? It's hard to tell a difference here. When we look at the histograms, we can see that there are differences. So we see more clearly that there's a lot wider range on A, it has lower lows and higher highs than B, whereas we see B is more clumped in the middle, right? So this one is kind of like more spread out. This one's more clumped in the middle. So this one, the histograms in this case, is giving us a lot more information. Imagine it that you're a person who, or it's one of your, your loved ones who unfortunately has some form of terminal cancer, and they have the doctors give them this choice. We have these 2 drugs that you can try. They're not going to cure your cancer, but they may extend your life. We have, in this case, if all you're told is on average, people who take drug A live 15.17 months longer, and people who take drug B live 15.25 months longer. If that's all the information you're given, I mean, okay, I guess I'll go with drug B because it's a tiny bit higher, but it's sort of a toss up, right? We don't have a whole bunch of information from this bar graph. All we can see is they're about the same. When we look at the histograms, if you're the person who is making this decision, right, between these two drugs, would you want more information or less information in this case? Right, in this case, we can see that with drug A, it seems almost like there's kind of like two pockets. You're either going to live, this lower amount, or you're going to live this higher amount. Versus with drug B, it's really more of in the middle. You're probably not going to live as short as you might with drug A. You're probably not going to live as long as you might with drug A, but you're probably going to land somewhere in the middle here because that's how drug B seems to work. So the histograms in this case really give us a lot more information than just looking here at these two, right, at the bar chart. So for number 7, which one would be more helpful to a person who's trying to figure it out? I would argue the histograms would be more useful because you get more information. You get a clearer, fuller picture of what's really happening. And number 8, so this is just reminding us our means for our two drugs. And on each of the figures above, I want you to put a mark showing where the mean of each drug should go. So this tends to be one of the trickier questions here. And that's because of this. The fact that our survival months are on two different axes. Here they're on the Y and here they're on the X. So on the bar chart, this is displaying the means. That's exactly what is being displayed. It's the mean for A is 15.17. The mean for B is 15.25. So our survival months, we can see if we look across, it's a little over 15. Now on the histogram, we don't have survival months on this side. So it doesn't make sense to cut like this, like it does on the bar chart. Here, it's flipped around and our survival months are down here. So we would really want to look at, okay, where's the 15.17? Where's the 15.25? Based on the numbers at the bottom, not based on the numbers at the side. So for drug A, this is the one that's 15.17, 15.25. So if I had to find on drug A where that mean falls, well, it's going to be just a little past the 15. The numbers at the bottom, we can just sort of imagine they would go the same for drug A, right? So I would say the mean for drug A is somewhere around here. Whereas the mean for drug B, again, it's just going to be a little bit past 15. It's not going to look that different here, but this is going to be 15.25. So here on the histogram, if we want to mark where the means are, we're going to mark them up and down. Whereas for the bar chart here, we're marking them side to side. Okay, I know that one it's pretty tricky for people. A lot of people get confused and they think, oh, the mean is up here, at the highest part. No, that would be the mode. That's the value that has the most. But it doesn't make sense to look at the mean because this is not months over here. This is just how many people. So if we want to look at the means, we have to look at the mean what? The mean number of months, the mean survival months. So we want to look at that axis and find our 15.17 and our 15.25 there. Okay, so hopefully that clears up number 8 for you a bit. Again, we can see those averages look pretty close, just like they do on our bar chart. However, look at all this additional information that we're given versus the bar chart. The bar chart, that's it. All we know are the means. Now, number 9, let's say the pharmaceutical company tells people, well, on average, people live about 15 more months with this drug. Is that true? Is that an accurate statement for each of those drugs? Well, I mean, yeah. On average, people live about 15 more months on drug A. That's true. On average, it works out to about 15. For drug B, yeah, same thing. People live on average about 15 more months. So it's not a false statement, right? This is a true statement that on average they live about 15 more months. Yeah, that's true. However, it doesn't really tell us the whole story, right? It's not super helpful. It is accurate, but it's not the whole story. It's not the most helpful. Now, if we consider which of these two drugs, A or B, is better described by the mean. Okay, so let's go back up to our histogram. Let me clean up a little bit. So, which of these two drugs is better summarized by that mean of 15? Well, with drug A, that mean of 15 kind of falls in this like gap region where there actually is nobody. Most people either live below that or they live above that. For drug B, if we look at that 15, well, yeah, most of the people are right in that region. They're right around that 15 months. So I would argue that the average of 15, like the average of about 15 more months, that's a better statement. It's a more accurate statement when we're talking about drug B than when we're talking about drug A. For drug A, it's not super accurate because like the 15-month spot, there's nobody there. 15-month spot for drug B, yeah, that's where most of our people are. So that it makes more sense when we're talking about drug B. Drug B is better described by the mean because drug B's values are more clustered around that point, whereas drug A's are way more spread out. Okay, so now a new drug comes to market, drug C. And here we're looking at all three on the bar graph or just A versus C on our histograms. So number 10, this one can also be a bit confusing. So how is drug C similar to drug A? I would say that if we look at the shapes, right, if we look at the shapes of A versus B, let me clean up again. Would you say that the shape of these two are pretty similar or pretty different? I would say the shape's pretty different. It's kind of like we almost get this, or like, I don't know, it's definitely more spread out and more flat for A versus B is more of like that traditional bell curve. So the shapes are very different for A and B. What about for A and C? Well, the shapes aren't really that as different for A and C. They're more similar because they're both pretty spread out, right? They're both spread out and they're both relatively kind of consistent, relatively flat. There's no like big peak like we saw with B. So I would say, how is drug C similar to drug A? Well, it looks pretty similar in the general shape. Like it's similar in that we get a wide range of values and there's no like one cluster. If anything, there's kind of like, again, this like two cluster thing going on here. So the shape is not that different. Shape is pretty similar. Now, how is drug C different from drug A? Well, even if we're just looking at this histogram, we can see from A to C, we're kind of shifting it a little bit, but it's harder to see that on the histogram. It's easier to see the difference between A and C on our bar graph. So we can see A is about 15 something. What's our average for C? It's looking like maybe it's more like 18 or so months. So I can really see that difference between drugs A average and drug C average better on the bar chart than I can in this histogram. Because in this histogram, it just looks a little bit shifted. It's hard to see. So I would say drug C is similar to drug A in its shape, the shape of the distribution. And how it's different from drug A is that, well, it has a higher average, right? That average is higher than drug A. Now, without knowing anything else and assuming that you want to live a longer period, which one would you rather take? Drug A or drug C? I would prefer to take drug C because on average, you get what looks like maybe about 3 more months, right? Yeah, sure, you may not get there. Sure, you may, there's a lot of variation, but still, it's almost like everybody's shifted up a little bit. And if you're wanting to live longer and longer is to the right, then drug C is the way to go. And it's even more clear on this bar chart, right? That the average for C is higher than for drug A. And if you want to live longer, go for drug C. So, when is it enough to look at the bar chart versus when is it more helpful to look at our histograms? Right? So, here in this situation, I actually think the bar chart is more helpful because we can see that difference better. Versus if the distributions look about the same, the histogram's not really giving us that much more information. Versus in the situation with A versus B, where the means are so similar, the bar chart doesn't really give us very much information at all. Whereas the histogram, we can see the shapes are different, and that makes a big difference in this case, right? So I would say something along the lines of when the shape of the distribution is similar, like A versus C, then let's go for the bar chart because the histogram, they're just going to look kind of similar. However, if the shapes are different, we really want to be able to see that, right? Here, where the means were about the same, but the shapes were different, the histogram was the better way to look at things. When the shapes are similar and the means were different, the bar graph's really the better way to look at things. So hopefully that clears some things up on classwork 4 for you.